Cheers. Hello everyone. Thank you for coming to my talk. First of all, before I start, I'm curious how many people are into application security, offensive security, vulnerability research, and exploration. Yeah? Okay, cool. I hope you enjoyed that. Cool. So, without further ado, I'll discuss about the Vesta control panel admin takeover, in particular about exploiting reduced seed entropy by random. If this stuff sounds a bit weird or confusing, don't worry, I'll explain everything in detail in the next half an hour, 40 minutes. So, a few words about myself. I'm a founder and principal consultant for Bridge. Been in this industry for a number of years now. I got a couple of certifications, in particular like the ones from offensive security, like, the classical ACP, OSEP, OSW and all that stuff. And lately I started speaking at conferences again. Spoke at Blue Hat in Israel, a couple of B-Sides conferences, besides Dresden, Kent, Budapest, and today of course besides Stoke. So thank you for that. What's this talk about? Well, obviously I'll be talking about application security because this is what I've been focusing for many years. I started as a developer, and then I realized, this is quite cool actually finding vulnerabilities in your own software and then in other people's software and try to create an exploit for it as well. Oops, sorry, skipped a slide. So what we're going to be attacking today is password reset tokens. This is one of my favorite attack surfaces to attack because it's authenticated. So you don't need any credentials, you don't need any privilege, just it's there, go for it. Yes, this is classified as cryptographic failure in OWASP top 10. I'm sure you heard about OWASP top 10. So it's quite high up in the risk matrix from OWASP. Now, a couple of words about the Vesta control panel. So, it's a web-based control panel. It's used to manage Linux servers, so you can manage your, web server, FTP server, domains, databases, whatever you need. It's similar to cPanel, VHM, Plesk, which are also quite popular as well. And in case you're interested, we did research in all these control panels, and if you want to know more, you can find details on our blog. It's written in PHP and Bash, which is quite interesting. I like PHP a lot because I started my career as a PHP developer, and it was one of the coolest things to hack back then, and it's still pretty cool. And as a side note, it seems that Vesta has been acquired sometime last year, around the time we reported this issue to them. This is how it looks like. It's a pretty simple interface, right? Exactly what you'd expect from a software like this. As I said, it's got various options to manage the web stuff, DNS, email, database, strong backups, right? All the usual stuff that you expect. But again, this is authenticated. I'm really interested in the unauthenticated attack surface. So, we have the source code. It's available on GitHub. So, actually, we're going to do a source code review, or as it's called, white box pentest. Because when we're doing a white box pentest, basically, we are increasing our chances of finding more vulnerabilities that are deeply hidden. I would say it's currently impossible to find and exploit such vulnerability in a black box manner. Like, there's no way to figure out how the password reset are generated, how you could exploit this, because you will see it's pretty easy to figure out that there's an issue with the password reset token if it's generation, but trying to actually exploit it's a whole different story. So, I did some research. There were some other CVEs that have been reported previously. They were quite trivial, like argument injection, command injection. So I was thinking, can I find one more critical? As some people would say, there's always one more. Before looking into the actual issue, because this was not, I didn't directly just went to the password reset and found it and exploited. First, I started reviewing the source code to get an understanding of the structure of the code, and I noticed some dodgy code patterns. So let's have a look first at some dodgy code patterns. The first one, it's in this script called add cron. So I think add cron, this is commonly exploited for command injection. So I'm going to try to, I hope it's somewhat visible. If you look at the top, there's no explicit authentication check. It does a check here if it's a post request, so this is trivial to bypass. It then also checks the CSRF token. Again, this is trivial, it's not actually an obstacle for attackers. And then it takes various variables from the post array, like minute, hour, day, month, etc. Like everything you need to set a cron, right? And then the next thing it does here, it calls escape shell arg to sanitize those variables, right? And then it executes with the exec command, with the exec command in PHP, it executes a script called vadd cron job. And it passes all those parameters that have been sanitized with escape shell arg. So, the only variable I looked at it, there's a variable passed which is called user, and this variable is not passed to escape shell arg. So I thought, that's interesting. Like, can we inject something? That would be cool. So yeah, can we inject something in user to achieve remote command execution? So, where is this user variable coming from? It comes from session. You can see here. It's taken from session and it's assigned user. So I thought, I read the code again, and I thought maybe I can find some sort of session pollution vulnerability or something like that. Maybe I can find something really dodgy to overwrite a session variable and from session user to overwrite the user and then inject into the cron script. I couldn't find anything, unfortunately, so this was a dead end, but overall I think it was an interesting idea. So the next dodgy code pattern that I noticed is in a bash script called vgen ssl serve. So basically, this script is used to generate TLS servers, right? When you create various domains, you then have the option to create TLS certificates with this script. So I reviewed this one as well. Again, there's no explicit authentication check at the beginning of the script. You can trigger the script unauthenticated, and it will continuously write TLS certificates on the server, which I found quite fun. Then again, the same thing happens. It takes the parameters from host, it escapes them with escape shell arg here, and then it calls another bash script. So I had an idea of writing a fuzzer for escape shell arg. I wrote two fuzzers, one was in PHP and one was in C with fuzzer. I thought maybe I will find a 0-day escape shell arg, but unfortunately again I couldn't find anything. So now let's discuss the real issue. This is the password reset process. When you trigger the password reset, you will receive an email similar to this one, which contains a couple of parameters. This is the user called admin because I want to reset for admin. And then there is the secret code, which I asked myself, how is this code generated? What can I do about this code? Maybe I can take over the admin account, let's see. So I started reviewing the password reset process. Essentially, when you're doing a password reset, it checks if the code that you submitted, that comes from the link, it checks if the code is equal to a similar code which is read from a file from the file system. And if these two codes match, it means, okay, this is a legitimate password reset attempt, so in that case, I'm going to reset the password of that user. Now, again, this I don't think is very visible, so I'm sorry about that. Essentially, the way this code is called internally is called an R key. That's what it's called. So we're going to look at this R key in a bit. Yeah. What is R key? Basically, every every user in the system has an associated file, which is, you can see here, users admin has a user conf file, and here is the R key, which contains that code for every user which you need to reset the password. Now, I need to specify something very important about this R key. This code is pre-generated. So, first time it's generated is when you install Vesta, and then this code is changed every time you do a successful password reset. So if you go and click 100 times reset password for admin, you will always get the same code. Only when you actually successfully reset the password, this code will be regenerated and rewritten in this file. So you have to know it to change it. This is important. So, the way Vesta works, basically there are some PHP scripts, and they call the bash scripts which do the heavy lifting. So, in the case of password reset, right, it starts in PHP, and then it calls this script called vchange user password script. And you can see that this script does two things. First of all, it changes the R key. So the password reset was successful. It will generate an R key, as I mentioned. And then, because it also needs to change the user's password, right? So it does generate R key and set the new password for the user. Now, when it generates the new R key, so which we'll use next time when you do a password reset, it calls this bash function called generate password. This generate password is used internally every time they need a new secret string like token, a random password, whatever. So let's look at this generate password function. This generate password function, it's a pretty standard function. I would say I've seen it many times when reviewing code for password reset. Basically, it takes a string called matrix, which contains all the alphabet characters. So from 0 to 9, then the all the uppercase, lowercase characters. It has a length of 10, so it will generate a string of 10 characters. And it will do a while loop until it actually generates 10 characters. So how does it work? It uses the random variable, right? The random variable, which generates a number between 0 and 32,767, which is, which is the maximum variable number that you can store on 2 bytes, right? And then it uses the modulo operator to get an index within the limits of this string. Basic stuff. Like I've seen this over and over. And so the most important thing that we're interested here is the random environment variable in bash to see how does it work, how does it generate random numbers. Is it crypto secure? No, it's not crypto secure. So, as I was trying to figure out how random the algorithm works, started doing some Googling, and luckily for me there is a gentleman called Jorian Volker, I believe, or I'm not sure how you pronounce it, and he created this cool project called Bash Random Cracker, which basically does a lot of the work that I needed to be honest. So, you can see some examples here. You can start Bash Rand with a command called crack. You give 3 random numbers, right? And what it will do for you, it will find the seed that was generated, which is 2 billion something. And then it will also give you the next 3 random numbers that would be generated. It's predicting the next random. And here I am validating. I'm doing an echo, and I'm echoing 3 random numbers again, and you can see that these numbers are matching with these numbers. So it found the seed, and it correctly predicted the next 3 random numbers as well. Another interesting thing about random is that it's deterministic as well. So here you can see that I'm initializing it twice with the same seed, and every time it will generate the same random number. So everything is very deterministic. Pretty cool. So here I reviewed a bit the source code because I was curious too. And I actually needed to understand how this algorithm actually works, because later I had to redo it in Python. You will see why. So here you can see how the seed is generated. First time if the seed is 0, it starts with a default value like 1, 2, 3, 4, 5, 9, whatever. And then it does some basic math operations. Everything very deterministic. And here, oh my god, this is really not visible. I'm sorry about that. I can barely see it myself. So, long story short, here it uses this seed. To generate a random number. It only does a check that if the current number generated is equal to the previous number, it calls itself again to generate a new number. So it makes sure that it doesn't generate two identical numbers in a row. So, everything is very deterministic with the random. The next question that I needed an answer was, how is the seeding done in Bash? So I started reviewing the Bash source code. And I found this function called seedRand, which does a few things here. It calls getTime of day, and it passes the TB structure. So basically this simply reads the current timestamp, the timestamp and the microsecond. And then it calls sbrand function, which does an XOR between seconds, microseconds, and the speed of the process. And if you look at sbrand, it has a parameter which is called seed. So this will be the seed, right? And the parameter type is unsigned long. So that means the parameter is stored on 4 bytes, and the maximum value will be around 4.3 billion. This is important. So, a couple of initial ideas that I had. How do I exploit this? The first idea was obviously I could brute force all the 4.3 billion values, but it's actually a very terrible idea. It takes weeks probably, and it's very noisy, and you probably could get caught as well. Somebody will notice something. Now, a couple of observations. I've been looking at this type of issues for a long time, and I can say that getBit is stored on 2 bytes in general. It's a small value, and it's brute forceable. Microseconds, which was used previously, the maximum value for a microsecond is 1 million, and you can store that value on 20 bits. So this is actually a small value and also brute forceable. Most important thing from the previous slide was the timestamp. So the question is, can I get an info leak, like maybe from the headers, whatever? Could we find, the question was, can I find endpoints that expose a useful timestamp? So the answer was yes, but they are all authenticated. So that's a problem, because I want to do everything unauthenticated. I looked for authentication by password or something. I couldn't find anything, unfortunately. Yeah, like I said, the useful timestamp is the timestamp at the moment of the password reset. And if you know any other tricks, I would love if you could share them with me. So I was out of ideas, and like I said, I love PHP, being an ex-PHP developer. So I started the next thing when I'm out of ideas, when I run an application like this, is to look at the PHP source code. So I'm like, okay, let me see, how do these guys in PHP do the random number generation? So I looked at some functions like LCG value and other functions that were generating like pseudo-random numbers, right? So I was trying to stay in the same area. And I found this function at LCG seed, which in a very similar manner to Bash calls getTime of day twice. So it reads the timestamp, it reads the microseconds, and then it does an XOR here. It does an XOR between seconds and microseconds but it shifts the microseconds left by 11. And here it does the same thing again. Get time of day, and then again it ignores seconds and microseconds, and it does a left bit shift by 11. So I'm like, what's with this left bit shift? Like, why is this needed? Like, I knew there has to be a purpose. Like, my spidey sense, like, this has to be security relevant. Because you could definitely get some numbers out of it without the left bit shift. Like, there has to be a purpose. What's the purpose? Let's look again at bash, just as a reminder. Call get time of day, it simply ignores seconds, microseconds, and the pin. No left bit shift anywhere. Is this a problem? That was the question that kept bothering me. And I spent some time thinking about this. And then I had like a revelation, or a eureka moment, or a moment, and I realized that these are the issues. So, the TV seconds, right? This is the current timestamp. It occupies 8 bytes, but 4 bytes are actually enough, and you can store any timestamp starting from 1970 to 2038. Then is the microseconds. As I said, these are 20 bits. You can represent any value between 0 to 1 million on 20 bits. Then there's the PID, return by get PID. This is also a very small number. I did a lot of testing, so I put some pressure on the system. The maximum value that I got was around 660,000 on an Ubuntu system, which again needs 20 bits. Again, so 20 bits was kind of like the maximum, like normally it's less. And then when we XOR these 3 values in bash, what's going to happen is essentially you're only going to change the lowest 20 bits, because there's no left bit shift. The upper bits will remain static, and that is the problem. So this was the aha moment. Now, I have to make a note here that it could be a deal breaker here for an attacker, but it would have to be like a really high number in the billions, which doesn't happen. I don't think the guys from the Linux kernel are that bothered or randomization, they don't really care about that. I think they have like a lot bigger issue to be concerned, to be honest. Sorry. So, by changing only the lowest 20 bits, we reduce entropy, and what's going to happen is that the new seed will follow it in an interval of approximately 12 days, around that timestamp. So it will be like roughly between, let's say the timestamp is now, 25th, the new generated timestamp will be from 19 July to end of July. That's kind of where it will fall. You can be 100% sure of that. So on the next slide, we'll calculate the minimum, where I put the lowest 20 bits to 0, and then the maximum with the lowest 20 bits to set to 1, just to show you all this. So it should be clear that the timestamp is really the only factor that matters here. The P, the microseconds, completely irrelevant. So I created this PHP code for visualization. You can see I created here a mask with the lowest 20 bits set to 0. I did the left bit shift 1 by 20 bits and then the -1. And then I created here a mask with the lowest 20 bits set to 1. And then I'm doing an OR operation just to make sure all those bits are set. This is just for visualization purposes. And here you can see the output. So this was the original timestamp which was around 8th of July last year. And then when I set the lowest 20 bits to 0, I got the day of 29th of June. And then I set the bits to 1, and I got 11th of July. So like I said, it's in a very small range. So I created a local exploit first to test all this, put this together. I extended bash random cracker. I added a method to brute force all the 4 billion plus seeds. Just because this was extremely fast, I discovered errors, so I said, perfect, this works fine. Because it's so fast, like it makes no point to optimize. And then I check if I can actually generate the password reset token, which is stored in the user conf file, as I mentioned. Of course, we don't really need to brute force 4 billion values. What I suggest is really just to brute force the timestamp for the last, let's say, 3 years in chronologically reverse order. And this is the new method that I added to Tiron on Cracker. Again, not very visible. Sorry about that. It's just like a very basic brute force. That's all it does. And here you can see the output in practice. So I added what I call bash run with a new parameter called password, and I pass the password reset token, and here it finds the seed. It brute forces all the seed, and it finds the one, and it says the seed is 28th of June last year. And this matches perfectly with what was in the file. So this works. And then the next step was, of course, I did this locally. Now I need to make it work remotely in a remote attack. So I created a Turbo Intruder script. In case you're not familiar with Turbo Intruder, like Turbo Intruder is a plugin for a burp suite, which has like a custom HTTP stack, which is designed to make the billion request attack to make it possible. So the POC is here in our GitHub repository. Once again, what I suggest is to brute force all timestamp. Let's say starting with now 2025 to 2022. So for the past few years, I think that's a very reasonable. Basically, I'm making the assumption that Vesta was installed in the last 3 years, or that the password reset happened in the last few years. I think it's a reasonable assumption. And what that means is there's 31.5 million attempts per year. In total, that would be around 95 million attempts, let's say 100 million, which represents a 90% optimization when you consider that we started from 4.3 billion, which is all the values that you can store in an unsigned long integer. If you'd like to see other Turbo Intruder optimization steps, we have a blog on hacking concrete CMS, where I exploited the double race condition, which was tricky, and there are some other things there on exploiting, on making it faster if necessary. And here you can see the glorious win. Basically, I am Turbo Intruder with my script, and I got the password set token here, and here I was already authenticated and got the admin account. That's it really. In case you're interested in some other research of ours, we hacked, like I said, a concrete CMS, where I got a remote code execution by exploiting 2 race conditions. We also had the field dating applications, where we found that a lot of data was publicly exposed. This was viral. And some other stuff that we did was we extended the AirBuddy's toolkit just to grab support from some DNS records, and basically to increase our chances that the phishing email will land in the inbox. That's it.
Got one question. When you optimize it more by sending password reset requests to your target account, you will lower the timestamp it will take about a second at that point.
Say that again, if I could send like multiple password reset.
So if you send a password request, reset request, say to the admin,
yes,
the token would have been updated shortly for the admin.
So, as I said, the admin token, you always get the same token.
Oh, okay.
Yeah.
No changes?
Only when you successfully reset it.
Okay.
So, like I said, there's one slide where it says you have to know it to change, so you can't just get a different token.
Okay, thank you.
Yeah.
So that detail is something that jumped out at me as well. So in this case, it would have been a lot easier.
Yes, it would have been.
But in general, it doesn't feel like good practice to me that the token model is actually valid.
Yeah, I mean, they decided to hard code it in a file. I guess.
I guess that's what I'm kind of getting at. Do you have any insight into why they might have made that decision?
Why they probably lack of experience, I guess because there was a slide where I said they did have some trivial injections, right? So now we're getting into more and more sophisticated stuff.
Right. It's ironic that actually the effect in this case was no hard to doing what that generated it.
Sorry, say that again?
It's ironic that the effect in this case is to make it harder to do your attack than it would have been if they generated it.
Are there any hard-coded accounts, as in many default accounts?
Just the admin account as far as I know. Okay. Yeah. And I was only interested in the admin account.
I was just thinking of a bunch of them that were used, then maybe you pass a request for them all about whether to do the scene prediction kind of thing with just the admin accounts.
Yeah. Because I remember I thought myself these questions here where it was something like I was really interested in the admin account being there, you know what I mean? So then I did some checks and I was like, oh yeah, the admin account is definitely there, it's definitely the first one that is created, so like, yeah, that's good. And then, because essentially it means I don't have to discover it, I don't have to do like an extra step to discover something like that. I would have looked for that if that was an issue, but unfortunately it wasn't the case.
One last question.
Yes.
Do you have any idea how many companies are using this control panel?
Yeah, there were like 35,000 at least exposed. Yeah. And I reached out to them. They weren't communicating, like they didn't really care. And then I did some more Googling and stuff. And then I discovered there was an issue on GitHub. And they said, like, yeah, we discontinued this, and now please use this control panel. Okay, I guess it's better than nothing. But you know, probably a lot of the companies that were using this control panel, like they probably don't Google and leave GitHub issues like I do, and you know.
Yeah, but surely it's like a bug bounty situation. There are not a responsible disclosure responsibility on your shoulders. Look, and I've told you, you've had 3 months. You're not interested. This is a real issue for your customers, and because you're not doing something, I'm now going to publish it.
Yeah, which is what we did exactly. Okay. We had to publish it. We said, okay, they didn't pass it, like we have to.
Well, when you've got to write in public, ignorance is not a good thing. And if they're not aware of it, and they're not doing about it, then someone's going to motivate them.
Yeah.
You might have already said this before, but I was curious. How long did it take your script to come up with the bypass?
A couple of hours. Yeah, again, depends. Like in practice, there's a couple of factors that would obviously influence this. Like, was the password reset last time maybe like 3 months ago or 3 years ago, something like that. I mentioned some previous research. There's things you can do to optimize Turbo Intruder on your side. Like maybe you could get a server co-located in the same, let's say if they're in Amsterdam, you can maybe also get a server in Amsterdam, right, in AWS. And that will definitely help speed things up. And there's a couple of other things.
Yeah, I bet also, like, with very complicated sites, I bet the majority of them are never doing a password reset on the admin account. So if you figure out useful date and public information, you can probably get very close.
Yeah.
You probably, when they said use the new control panel, did you look at that control panel too?
I only checked the password reset issue, and you did, I think it was crypto secure now.
Okay.
So I was like, okay, well, if it's crypto secure, that was the only thing that I actually cared. And other than that, I didn't. But the code looked like pretty similar. It was maybe like a rebrand. This issue was fixed, and other than that, I didn't really look, to be honest. I was only interested in this.
So you wouldn't use to manage your servers?
This one? I'd have to review it myself. Yeah.
If there's no more questions, thank you again.
Thank you.